I'm Midshipman Third Class Statista Henrik R. from MD2 Bravo Company. And go ahead mag-say sa'yo. So in today's topic, we will talk about the position determination in the subject of navigation tree. It will primarily focus on the use of position lines and position circles to plot the position of the ship at a sea position line. It's a focus of all possible positions of the vessel and position lines, and it can be derived from terrestrial observations, or uh, it can be derived from celestial observations, or electronic aids to navigation that are used in modern times. So today, we will examine how positions line are obtained from terrestrial observations. So we have discussed the two observations before starts of the position lines from terrestrial observation. So we start from visual bearings, uh, and and visual bearings can be obtained by using the gyro compass, which gives us the true bearing, and the ship's magnetic compass that gives us the compass bearing. So because the ship's magnetic compass is also influenced by the ship's structures in the cargo on board, we do not call it compass bearings. We do not call it and we do not call it magnetic compass bearings. We basically call it a compass bearings. So electronic means of position fixing involves use of the ship's radar and the echo sounder, as it will shows in the presentation. So we will talk about the uh, visual bearings using the gyro compass. In this case, for example, you can see that the bearing of the lighthouse is obtained using the gyro compass. Now, since the gyro error, let's assume the gyro error is zero. In this case, the gyro will not coincide with the true knot, and thus the bearing obtained of the lighthouse becomes the true bearing. In this case, we can see the bearing about 3 to 5 degrees with the bearing of the lighthouse obtained as say 3 or to 4. So in this scenario, we can say that the bearings of the lighthouse is 345 degrees, and with the bearing of the lighthouse obtained as say 345 degrees, we know that we are somewhere along the line of the bearing looking towards the lighthouse. All right, so in order for us to plot the position line on the chart, we lay off a line of bearing. In this case, it is 345 degrees to leading towards the symbol of the lighthouse. All right, so always take note that the arrowhead on this position line points away from the lighthouse, as we are somewhere along the line away from the lighthouse. So in the previous case, let us always take note to avoid making mistake of plotting the position in the wrong direction, because always always remember that the compass is on the vessel and we are looking out towards the lighthouse. The bearing observed was taken out the magnetic compass. The magnetic compass bearing is being obtained, and it should have been converted to the true to be plotted as a position line on the chart. Now let's talk about the transit bearing. Two objects are described as a being observed in transit, and when they can be seen in a direct line with each other, as we can see in the picture below on the chart, because we can align a ruler on the chart between the objects. A line can be drawn on the chart. Thus we can also effectively use this line of transit as a position in line use of the transits as leading marks or stern mass. Is really convenient and practical to the navigator in times of running in for an anchorage, pilotage in confined waters, and approaches to harbor where more frequent position determination is required. So it's also a powerful method and of determining your gyro or magnetic compass error. So this basically is the most efficient when determining our gyro or magnetic compass error. This can be a different approach when determining our compass error. So, furthermore, we can obtain the true bearing, true transit bearing to the chart, and then we can compare it to the transit bearing that we observe using the gyro compass, and we can obtain the any difference will be the gyro error. So for the next slide, it will become a we will talk about the radar ranges and the radar bearings from terrestrial observations. In this scenario, the north of setting of the radar gives us gyro stabilize, and the the relative shifts head up gives us relative bearing. So this is the we have to very careful of whether you are getting relative bearings or true bearings, because it really depends on the setting of the radar that we put your that we put. So all right, we will now talk about a position line, and it can also be a obtained and drawn to the chart if we determine the distance you are from the charted object. So the distance can be determined by the radar as as well as the rising or tipping ranges of lights, as we talk about that, as well as the position circle is drawn onto a chart using a set of compasses. The distance is measured off against the latitude scale. The pivot of the compasses is then placed towards over the object in an arc ascribed from the object in the vessel is somewhere on the position circle, or or in the terms of radar ranges on the radar, you can we can obtain the range of a charted object detected, and we can use it as the position line. Since this position line is a range, it should be marked off on the chart as an arc or a circle around the object using a pair of compasses. So uh, so we can compare the what we could see on the radar screen and on the as on the what we have plotted in this video. So now we will talk about the line of soundings. In this line of soundings, we will talk about the depth contours. So we observe the depth contours in the navigation one in the UKC policy. So in the depth contours and charts are lines are drawn joining the places of equal depth. As you can see in the 5 to 10 to 20, it is basically lines joining places of equal depth. Mariners should very aware about using these depth contours as a means of position determination, as these are not intended for use as position lines. However, soundings give useful indications on the general position of the vessel of the coast and the proximity to the hazards and dangers, especially when other charted coastal features are there. So the depth indicated on the chart is a charted depth, or the depth of the water, or the or as we all know, it is the chart datum. The depth given on the echo sounder is a distance between the transducer and the sea bottom, so that it has to be corrected for the depth of the transducer and the height of the tide in order for us to obtain the chart.
So position line, this one it will provide us an indication of our ship, or now especially this is used. This methodology is used especially in those cases when the availability of other objects, terrestrial objects, are scarce. So we will talk about the simultaneous observations of the obtaining position lines. So when simultaneous observations have been made and the corresponding position lines are plotted together on the chart, we will say that we have determined our position by affixing. So position fix is the intersection of the minimum of two or more position that was derived at the same time. So two is good, and two or more will be better. So the symbol for our fix is an encircle that we can see here. It is a standard symbol. A machine should not use this for anything else on the chart. Since the fix represents the determined position of the vessel for a particular time, the symbol for a fix must always be accompanied with that time using a 24-hour clock. As we saw before, that in the terms of number of position lines now, although we need a minimum of two position lines for our fix. So we should always endeavor to obtain a third for greater degree of certainty. So always remember the choices for objects for boxing, the 4-1. So now I will explain the fixed reliability. So cockhat has caused by identification errors, time delays, plotting errors, instrument error. So it is because sometimes that it was identification for errors or time delays, and plotting errors as well as an instrument errors. So that's why it's a good idea for us to use the more than two or three position lines that are located at the wide wide angle of, so so that two fixes are reliable. So the accuracy of effects can be influenced by your errors in obtaining position lines by the navigator or time delays. So always recheck and replot fix. In such scenarios, we will always make sure that to recheck and replot our fix. So in here we can see that there are three position lines from the objects which are widely, and so when we take 10 lines from objects which are widely located, we can see that in this case, of course, they are intersecting at a very good angle, and they are all intersecting at the same time, in the same point. In that case, our fix will be a good, and this is a reliable one, uh, and we will call it a good angle of cut. Then, but sometimes when we get a cockhead, we will normally cockhead are resolved by finding the center of the triangle. So the center of the triangle, but in terms of the coastal navigation, we will always resolve cockhead by replacing the vessel closest to the nearest navigational danger. That's how we will resolve it. So when at least three position lines are plotted, uh, this kind of errors can occur, especially if the objects are not widely. So as we can see in the red lines, this cut sometimes becomes a little lower, because of this is called a term of bad angle of cut. And here the three position lines are not intersecting at the same point, due to which they can be some fancy position in position fixing. And this case always place your vessel to the nearest danger. So in order for us to have some I mean that on our hands. Small cuts are common, and it can always be expected in most circumstances. So we navigators won't be alarmed on the ship if we get that obvious. The ship sometimes it's not too obvious. It is possible to get required bearing from the objects, which are absolutely perfectly placed on all positions. So it is normal.